Today we want to briefly go over two causes of X-ray film fog. In X-rays, a fog is an unwanted darkness in the film. And basically there are two reasons for this, two main reasons we're going to go over today. The first one has to do with radiation that is scattered, and there's two different forms of that scattering before it touches the film. Now the first form is just Thompson scattering, also called unmodified or coherent scattering. This just means a low energy photon interacts with matter, is redirected or changed direction before it then encounters the film, and because of this change in direction due to encountering the matter as a low energy photon, when it finally reaches the film, it shows up then not as you wanted the contrast, but as darkness or this fog. So Thompson scattering, or unmodified or coherent scattering, is a simple low energy photon changing direction due to encountering matter. That change in direction as it reaches then the film results in the darkening of that portion of the X-ray film or the fog. The second form is called Compton or incoherent scattering. This one's a little more complicated. Compton or incoherent scattering basically means you've got the high energy X-rays are expelled. That's what you're doing to try to take the picture. And as they are expelled, the outermost orbit electrons are expelled from their nucleus or from their atoms. They're sent out. And as they go out, they begin to interact with other matter. So you've got a positively charged atom loosely coupled with a negatively charged Compton or recoil electron. This original then photon, which was there, changes direction as it interacts with this, as this comes into contact with the matter. If the change in direction is not too severe, you still have all the energy of the photon coming in, but it's changed in direction, and it arrives at the film then as fog. So this is just a simple matter of connecting with matter, change of directions as a low energy photon comes in as fog. But this one here, you've actually got the electrons in the outermost sphere, basically the outermost orbit, interacting with matter. This positively charged atom gets loosely coupled with a negatively charged Compton or recoil electron, and basically that coupling and change of direction then results in the photon arriving at the film, not in a direct manner, but a changed direction resulting in the fog or the darkness in that particular part of the X-ray film. This has just been a basic overview then. There's obviously a lot more that could be said about this, but when we talk about fogging in X-ray films, what we're talking about is unwanted darkness in the film, which is caused by scatter in the radiation before it touches the film. Things that you can do to help with this are adjusting the amount of time, the time lapse in taking the picture, certain manipulations you can do to help minimize this scattering effect that happens either on just a coherent, unmodified, simple level, the Thompson scattering, or in a much more complicated Compton scattering involving electrons being interchanged, redirecting the photons and all that kind of stuff. So essentially these are the two things that we talked about today, Thompson scattering and Compton scattering. If you'd like to learn more about this and related matters, then underneath this video there's a link. If you'll click on that link, it'll take you to the website that has that information, and while you're on that website you'll also find a link to an ebook that's ready for immediate download.